stoichiometry part is just the mole to mole part. That's the only part that's stoichiometry. Okay, everything else, Mihan, unplug. Okay, everything else is converting. So what do I mean by that? So let's take this for example. Here, what are they giving you? They're giving me my 2.2 moles. Very good. So that's my given, right? You always write your given down first. Okay, of NH3. Now I noticed yesterday you guys were doing very well. You have the numbers where you're supposed to. But that's only short term, the mole to mole, right? We need to make sure that you're putting the units, the mole, along with the chemical. Because now you're going to be doing conversions and you need to know where you are. Okay? Whoops. That's crazy. Okay, so now, what is it that we are looking for? The grams, So we're looking for the grams of H2. And that's the old formula that we had before from last chapter, right? Grams equals what? Your moles times your molar mass, right? Guys, I need to know where you are. Okay, but before we can do that, we have to find the moles of water first, right? Do we have moles of water? No, you have moles of NH3, right? So you're going to do your stoichiometry, the mole to mole thing, which is what we've been doing for the past couple of days. What goes on the bottom? The moles of NH3, right? Okay, what goes on top? The moles of H2O. And these numbers, those circles are a little off, should be coming from here. Okay, so what's my mole for water? 6, very good. And what's my mole for NH3? The 4, very good. Okay, see, and so that gets rid of your moles of ammonia. And this gives you the actual moles of water. But is that what we're looking for? Is that what we're looking for? Nope. We're looking for what? For the grams of water, right? So, to get those grams of water, that means that I have to get rid of this mole of water. And for every 1 mole of water, I have what? How am I going to figure out those grams? The molar mass, right? So now how much does water weigh? Yep, because oxygen is 16, hydrogen is 1, 1 times 2 is 2. So 2 plus 16 is 18. That's my molar mass. Okay, so all of this will give me my grams of H2O. You see how this part is the stoichiometry? And then this part is just the old stuff we did the last chapter. Figuring out the grams. Grams is moles times molar mass. That's it. Okay? I mean the moles times your molar mass. Okay, so now you just do the 2.2 times 6 times 18. Get out your calculator. Guys, 237.6, and now you're going to divide by 4, right? So how much is that? 39.4, 59, 59.4. Okay, did everybody else get that? Did everyone else get that? Yes? Okay. Guys, I can't help you if we're not participating, okay? I can't know where your mind is unless you tell me. All right? Okay, so do question 2. You tell me what to do. Hi, sweetie. What's my given? The 0.3 moles of H2O. That's my given. Very good. Okay. What am I looking for? The grams of O2. So because I'm starting with moles, I have to do the mole to mole thing first. That's stoichiometry. And then I can go to the last chapter and find grams, right? So how can I find my moles? Moles of what goes on the bottom? Of the H2O. And then moles of the O2 go on top. Very good. Where do I get these numbers? The coefficient, right? Okay. So what number goes on top?
5.
Yep, very good. What number goes with water? The 6. Very good. Okay, so now this gives me my moles of O2. Very good. But is that where we wanted to stop? Nope, we need the grams, right? Okay, so what's my next step? This unit goes where? On the bottom. Very good. So a mole of O2, 1 mole. How can I figure out my grams? The molar mass. And oxygen weighs how much? 16. Very good. And 16 times 2? 32. Very good. So this cancels out your moles. Now, can I calculate my grams of O2? Yes, right? So 0.3 times 5 times 32 is how much?
48.
Okay, and now we're going to divide by 6.
8.
48 divided by 6 is 8. Yes?
Yeah.
Okay, so 8 grams of O2, Michael. Okay. Where is it that we're stuck? Where do we need another example? Are we sure? Guys, I can't know where you are. You need to ask me now, because these are very long. I can't do the same question 30 times. Ask me right now, where are we stuck? Where do we need help? I know this is old stuff combining with the new stuff that we've had all week, right? The multimole, we've got it, right? Did we feel better about it yesterday for the lab? Okay. So now all you're adding is the old stuff, just figuring out how to get the grams. So once you have the moles, just moles times the molar mass, right? Okay, are we sure? We don't have any other questions. Okay, on your worksheet today, I had some examples, but I guess this first worksheet is just a little refresher of what we've been doing the last chapter. So if you have grams, you're going to find moles. If you have moles, you're going to find grams. So look at this top one. How do I find grams? What's my formula for grams? We just said that earlier. Well, how do you find grams? Moles times your molar mass. Very good, Miha. Okay. It's going to be times your GFM. Okay, so here, how am I going to set up that problem? 2.5 moles of your potassium cyanide. And because 1 mole always equals your molar mass, mole of KCN is going to be on the bottom, and your grams of KCN are going to be on the top. How am I going to find this number? Can somebody get that? How are you going to find the KCN? K weighs how much? 39. Carbon weighs how much? 12. And then nitrogen weighs how much? 14. So we're going to add all this up. 39 plus 12 plus 14. How much is that? 65. So you're going to have 65 grams up here. And so then what's your last step to figuring out those grams of KCN? What are you going to do here? Bless you. What are you going to do there? Multiply. Very good. 2.5 times the 65 is going to give you that answer. Okay. All right, let's go ahead and go to the next one. So here, they're giving me the grams. I have to find moles. What's my formula for moles? This goes to the old chapter. Mija, we need to be unplugged. It's grams divided by your molar mass. Very good. Okay, so here they're giving me how many grams? 2.5, and that's very light. 2.5 grams of your potassium cyanide. Very good. Remember that your objective is to stop at the unit that they are asking for, okay? So here, we're going to do what? We're still going to figure out the molar mass, right? The 39 plus the 12 plus the 14, which we said was what? 65. So 2.5 grams divided by your 65 grams per mole. This is the old stuff, right? This will give you the moles of KCN. Okay, so you see how we're doing these? This is the old stuff. Do we have any questions on this? This is how you're going to use the conversions for that next page, for the other page. Yes? On the other side? On where, mija? On this side? On this side of the page? Okay, number 4 is what? Huh? I don't know which one's number 4 because my page is cut off. So what is it that it's asking? Oh, okay. So remember that here you're still looking for moles. Your formula for moles is still grams divided by your molar mass. But don't forget that dot here, it's not math, right? They're chemicals. You have a solid and a liquid. So that dot, you're going to ignore it, and how are you going to get the molar mass? You're just going to add everything up. Very good. Okay? You're going to ignore that dot, and you're just going to add everything up. So copper is 64. Sulfur is 32. Oxygen is 16, and you have 4, so 16 and 4, that's 64. And then you're going to add 5 times 2. How many hydrogens is that? 10. And then 5 times 16 for oxygen, that's an 80. 5 times 16 is 80. Then 80 plus 10 plus 64 plus 32 plus 64. That's going to be 250 grams per mole. That is your molar mass. Okay? So that's what you're going to use. You're going to take the grams divided by the molar mass to figure out those moles. Yes? Okay, let's look at the other side. Let's look at the other page. On the bottom, I just saw something right now. Look at the very bottom. It says, how many moles of water are there in 1 liter? A long time ago on some of the notes you had, I gave you, remember Avogadro's number, 1 mole is 6.02 times 10 to the 23rd? For volume, it's going to be 22.4 liters. Okay? So I'm not going to give you the answer to that question because I want you to do it. So like, let's say I gave you 5 liters, and that was your given. If my given was 5 liters of water or whatever it is, how can I do this conversion? Remember, always look at the unit. What's going to go where? The liter's going to go where? At the bottom. Very good. So your liter's going to go here of H2O. And then the mole that we're looking for is going to go on top, right? And remember, this number comes from your conversion. What's my number for mole? 1. And what's my number for liters?
22.
The 22.4. Okay, and that's how you're going to do that problem. So this gets rid of your liters, and now you can have your moles of H2O. Okay, so you're going to do it just like that, except you're going to use the number that they're giving you, which is 1 liter. Okay, yes? Let's look at the other page. Oh, wait, before we go to the other, here you're going to set it up just like the examples we did at the beginning. You're going to look for moles. I mean, you're given the moles, but you're going to look for grams. Okay? So let's look at number 9. Let's set that up. What's my given?
potassium bromide.
Very good. 4 point, oh, can you barely see the blue? 4.3 moles of potassium bromide. Remember, this is where our nomenclature comes back into play. Okay. And what is it that we're looking for? The grams of potassium chloride. Now, before we look for grams, we must look for what? The moles. So you have to do that stoichiometry first, because we need to get rid of potassium bromide, because we no longer want potassium bromide. We want a different chemical, which is the potassium chloride. Very good. Okay. So what am I going to do to get that? The moles of what? Of potassium bromide goes on the bottom. And what? And the potassium chloride goes on top. Very good. Okay. So what's my number here for potassium chloride?
2.
The 2, because that's coming right off of your coefficient. Very good. Okay. And what's my coefficient for potassium bromide? 2. So this cancels our potassium bromide, and now we have KCl, right? We have our unit, but do we have what they want? No, because we have the moles, right? So they want the grams. So what do we do here now? Mole of KCl on the bottom. Very good. And the grams of KCl on top. Very good. Very nice. Okay, so now how do I find my grams of KCl? What is that? To find grams, it's moles times. This is where your formulas come into play, guys. It's the old formulas. To find grams, it's moles times molar mass. Okay? And so what's my molar mass of KCl? I'm sorry, I didn't hear that. Okay, so 39 plus 35 gives you that 74. Okay, that allows you to cancel out the KCl. And now can I multiply and divide to get my grams? To get your grams of KCl, yes. Okay, so you're going to multiply 4.3 times 2 equals, or you can actually 4.3 times 74 equals, that'll give you your grams, because this is going to cancel out, right? And that's it. Okay, you're just going from moles to grams. All right, where do we have questions? Where do we have questions?
So I'm just going to multiply that 4.3 times 74.
Now, let's say you had a different number here. Let's say you had a 3 instead of the 2. You would do the 4.3 times the 3, and then times the 74 equals, and then divide by the 2. But because those two are the same number, it actually equals 1, right? So that's why 4.3 times 1 times 74. But if that's confusing, just do the 4.3 times 2 times 74 equals, and then divide by 2. And you can't go wrong that way. Okay? Okay, anything else? That's a good question. Anybody else? Mr. Starbucks, no? Okay. All right, go ahead and get started. You need to do both sides. Remember, to get credit, you must show the work. Thank you, sweetheart. I appreciate it. Have a good day.